lab procedure, which for every AP test, there's always one where either you have to analyze a lab or you have to just develop a procedure yourself. And right now, we'll develop one for our own. This is Hooke's laws and springs. You guys have this paper if you want to work on the paper as I go along with it. So it says, consider a spring and a rubber band. Both have elastic properties, which means that as their lengths increase, they exert increasing amounts of force. Let stretch length represent the difference between the spring or the rubber band's length while it exerts force and its length while it exerts no force. Carlos suggests that both the spring and the rubber band exert a force that's directly proportional to their stretched length. Describe a procedure that Carlos could perform to make measurements that would allow him to show evidence for his claim. Assume that Carlos has access to a spring, a rubber band, and equipment typically found in a school physics laboratory. Describe the measurements to be made and with what equipment, include enough detail that another student could follow the procedure, draw a diagram of the experimental setup. All right, so the first thing that I would want to do in the procedure is I want to figure out an easy way to stretch the spring and to stretch the rubber band. And so I'm going to start with a crossbeam. I don't know if you've noticed that there's holes in the desks, but I have cross beams that go in there. The second thing that I'm going to do is I'm going to suspend both the rubber band and the spring from the cross beam. Note that everything that I'm drawing, I am labeling, because it says labeled diagram. The other thing that I need to measure is the applied force and the string length. To measure the string length, I'm going to put a meter stick behind them. And then I'm going to have a set of masses. So I think that's good for a labeled diagram. So the first thing is I'm going to set up cross beam with rubber band, spring, and meter stick. As in diagram. Second thing, I'm going to take known masses All right, I'm back. We had the class change. So I went out and supervised, so there was no fighting. All right, so I'm going to take known masses and suspend from rubber band measuring the stretch length. And I'm going to do the same for the spring, and I'm going to do 2 and 3 for 6 different masses. And that's it. Any procedure that they would ever ask you to write, you should be able to do in 4, 3, 5 lines. It should never be longer than that. The procedure is what you're going to do. What measurements are you going to make? Now, it isn't what you do with those measurements, which would be the next part. How would the measurements be analyzed in order to test Carlos's claim about the behavior of a rubber band and a spring? When they want you to analyze data, this word analyze means they want you to graph. So looking at our equation for an ideal spring, this linear relationship that we're looking for could be achieved by graphing mass times 10 versus stretch length. If Carlos is correct, the data should show a linear Now, why did I multiply this by 10? I want this to be a force. And x is our stretch length. Carlos collects the measurements shown below. Graph the data on the axis below. Okay, so I'm going to make a key. I'm going to make the spring blue, and I'm going to make the rubber band red. So the force applied of 10, for the rubber band, it stretches 0.1. So 0.1 comma 10. For a force applied of 20, it stretches 0.14. For 30, it's 0.17. For 40, it's 0.2. And for 50, it's 0.51. Sorry, no, it's 0.22. For the spring, at 10, it's 0.11. At 20, it's 0.2. At 30, it's 0.29. At 40, it's 0.4. And at 50, it's 0.51. So which one is showing linear behavior, or both of them? The spring shows linear behavior. The graph arranges the data in a line. The rubber band does not show linear behavior, a linear relationship. The data is not linear. Did I answer the question? Yes. I didn't do anything with the laws or laws of physics. But he didn't ask that. I contrasted the situation, and I did use physics vocabulary.